Okay, in this video I'm going to show you, or attempt to show you, how to use DMAG5, the depth map automatic generator. So first let's see how to download it and install it on your machine. So for that you go on to my blog, 3dstereophoto.blogspot.com, go in 3D software, and then look for ugosoft3d 5, something 5. Okay, so it's here. There are a bunch of them, different versions. So there's a 32-bit version, which I really don't recommend you using it. There's a 64-bit archive, but this one is it has a graphical interface, which I don't particularly like using. So my preference is always to use the non-graphical user interface, or GUI version, which is this one, no GUI. So ugosoft3d 5 no GUI x64.rar. And also it's probably a good idea to look into this blogspot post that explain what the parameters are for DMAG5. So it's always a good idea to look in there, and this explains all the parameters. Okay, so let's go back to here and download this one, the no GUI. So again, you are taken to Dropbox, and there should be a link upper right to download. Here we go. So download that guy direct. Okay, so let's get out of here now and go into the download. So here it is. So double click to extract. Of course, I'm assuming that you have WinRAR installed on your machine, but I think with Windows 8 and above, you don't need WinRAR to extract RAR archives. So anyway, so let's extract right there. Okay, so now this one. Again, there should be a test directory for DMAG5. So you go in there, and I have basically a sample test so that you can make sure that you properly install the software. So there's a thing that you have to change right away. So it's a DMAG5.bat file. Edit this guy, and you're gonna have to change that line where the executable is. Let me get rid of this stuff, because this line has to be changed. So you need to know where the exec is. It's one folder above here. So let's see, DMAG5. This is the exec, and there is even a manual that you can peruse. It should have the same thing that's on the blogspot post. So okay, so that's the exec. So, and the path to the exec, you can get it through here. So you copy that, and then you go back to the test directory, and you edit this file. This file. Okay, and you replace this guy with what you copied. So here I'm pasting. Okay, done. So let's just save this guy. Save, let's get out, and now I'm going to double click on this to make sure that it runs. Yeah, so it runs. We'll go back on the parameters later. I just want to make sure that it runs. It shouldn't take long. So then I'm going to show you how to use your own images. Let's see how long it takes. It's almost done. Okay, so it's done. So now if you want to use your own images, what I recommend doing is make a copy of this test directory, the DMAG5 test. So copy and paste. So now this is going to be where you're going to put your input files, your images, your stereo pair. And let's just get rid of what's not needed, because this is all output. So let's get rid of all this stuff. Okay, so now we are ready to run DMAG5 on your own input files. So what we are going to do is that we are going to take the output from ER9B. I mean, if you had a look at my previous video, I used ER9B to rectify a stereo pair coming from an old stereo card. Those two here are the output from ER9B, and those are going to be the input to DMAG5. So we're going to put those into that DMAG5 underscore test copy directory, and we're going to run DMAG5 on those rectified images. So let's make sure that the names of the input is correct in the input file. Probably isn't. Yeah. So here I'm going it's going to be rect image underscore l dot png, and the other one, the right one, is rect image underscore r dot png. And here I have to put the correct range for the disparity. So I need to get the minimum disparity and the max disparity from that ER9B directory. So let me go back there. So let me go back to this guy, and it should be in this file, this underscore range. And it's minus 83, 118. So I'm just going to plug that in. Minus 83, 118. So that's the mean disparity. That's the max. And here I'm going to change to PNG. PNG. Same here. PNG. PNG. Yeah, the parameters I explained in that Blogspot post, but briefly. So this is the output, left and right depth maps. This is the also output occlusion maps. Occlusion maps, it's going to show you, if it's white, it means that the disparity is probably correct, and if it's black, there's a doubt, so the disparity is likely to be incorrect. Of course, you want as much white as possible in those when you look at them, but sometimes, especially with stereo cards, it's kind of hard to prevent the black areas. This is the radius. This is the ratio between using the intensity or the gradient. Don't worry about this. Don't worry about that, and don't worry about that. Oh, this is the downsampling. That you need to worry about it. Unless your image is quite small, you may want to put a 2 here. If you put a 2, the image is going to be downsampled. The images are going to be downsampled by a factor of 2, which means that the DMAG5 is going to run 4 times faster. So it's always a good idea to use 2 and see how long it takes. And if you want to have more accurate results and the images are not too big, you can switch to 1. That is no downsampling. But when you start, you should really use 2. And here, really the only parameter that matters is probably that one, the radius. So you can try 16, and I think I'm going to try probably 32 and even 64 for this particular case. Okay, so let's save this guy and run the thing. So let's go back to this, and yeah, we should be ready to run now. So double click on the DMAG5 and just make sure that everything looks correct. So radius 16 here, and here you have the mean and max disparities, -83, -83, 180. So, and I got the downsampling factor 2. So what's going to happen is that it's going to create 2 depth maps, one depth map for the left depth map and the right depth map. You need to compute both of them so that you can see which disparities are likely to be correct. Then, because you can compare the 2 disparities on the 2 different depth maps. So that's why you do both of them. It shouldn't take long. Okay, so it's almost done. Okay. Yeah, so this is the output, the left depth map, and this is the right depth map, and this is the occlusion map. So if you have a look, for instance, at the left one, everything that's white means that DMAG5 was pretty optimistic about the value he got. So he accepted, DMAG5 accepted whatever he computed as correct. But whenever it's black, it means that DMAG5 was not confident in the value. So what happens in that case is that everything that's black in the depth map is basically removed and recomputed using neighborhood information, which is what's going on here, detecting occlusions, filling occlusions, and smoothing occlusions. This only happens, all that stuff only happens in the pure black areas. So let's have a look at the disparity map. I'm only want to look at the left one. Here you have some issues, but I mean it happens, especially near the boundary. But other than that, it looks pretty good. I mean, we can certainly fix up a lot of stuff here, and we are. But for now, we'll fix it up later. But for now, I just want to try increasing the radius. See if it what kind of differences it makes. So yeah, let's do that. Let's see if we can improve things by increasing the radius. Okay, so what I did is I made another copy of that copy. So this one is named 32, this one is named 64. On the 32, I'm going to use a radius equal 32, and on the 64, I'm going to use a radius equal 64. And we're going to compare those two with the one that we did with radius equals 16. So let's go into the 32, and let's change from 16, the radius, to 32, and we're going to run that one. So let's save this guy, and let's get out, and let's run the 32. So let's double click. So let's make sure, yeah, so we have radius equal 32. And everything the same. Everything else the same. And to see if things improve, usually I look into the changes in the occlusion map. If the black areas, if there are fewer black areas, it means the depth map is better. So that's how I compare depth maps when I do runs like this with when I do run like this, where I change one parameter at a time and see if it's better or worse. I just look at one of the two occlusion maps. So that's why I have the GIMP here ready to go. So let me load the 16 one. So this one. So I'm going to load the occlusion map, the left side. So I'm going to put that on the back burner for now. Okay, so this one is done. So now I can load the 32 on top. So open as layer, and I'm going to open the 32 that just completed. So I'm going to open this one, and I'm going to compare the two. So this one on top is the radius 32. This one on bottom is radius 16. So let's compare the two. Okay, so here there's not much of a contest here. Clearly a radius equal 32 is much better. So now what I'm going to do is I'm going to try 64. So let's go back one directory up. So go into 64. Let's change the input file. Change 16 to 64. Save this guy. And let's run it. Make sure radius 64. That's correct. And okay, so right now this is radius equal 32. I mean, even if the depth map generator produces a perfect depth map, you're always going to have black areas. either on the left side of objects or on the right side, depending on whether you're looking at the left or the right occlusion map. What you don't want to see is black all over the place. Little clusters of black. Like here. This area, for instance, on the left side of that goose, that you cannot do anything about it. It's always going to be there. Same thing here. Same thing here. Anything on the left side of an object that's in the foreground. That's in the foreground. If you look at the right occlusion map, it's going to be on the right side. This is perfectly normal. It corresponds to the occluded pixels. Okay, so now it's done. So let's go in GIMP and see. Let's load up this one. Okay, so this is 64. Yeah, so at this point I don't think it improves, so I think I'm going to stick with this one, the 32. And so let's get out of here. So to me this is the best one, the 32. And that's the one we're gonna keep working on. This one we're gonna try to get rid of the bad stuff here on that side, and maybe here and there are a few specks that need to be removed. So at this point it's probably a good idea to check the quality of the depth map before going further. So yeah, let's do that right now. So if you go into depthplayer.ugocapital.com, you can load your reference image and your depth map and see the 3D scene. Here, because the image size is 2400 by probably the same 2400, something like that, so it's like 5 or 6 megs. You may want to downsample here, so I'm going to put, instead of 2, I'm going to put a 4. Otherwise it may take a while to create the scene. So choose file. So I'm on the 32, radius 32, our base depth map. So here you want to load the rectified image, the left one. Here you're going to load the left depth map. And then create model. And what I do is that I switch to point cloud. And then what you do is that you just move around a little bit to make sure that everything is at the right place. So what I'm gonna do next, I'm gonna try to remove all that stuff here that's wrong. But I think I'm gonna end the video here and start a new video to explain how I remove the bad stuff. So until then, see you around.